Okay, hi everybody. Hi again. Just to finish off what I was saying here, this is how we calculate the confidence interval, the 95% confidence interval for our population mean from a mean of our sample and a standard deviation of our sample, or from the standard deviation of the population and our sample size. So this is our 95% confidence interval because we've used the area which gives us 95% of our total population. So in between those two there's 95% of our population. So we have a 95% confidence about this interval. And then if we wanted to increase our confidence, we could increase the area that we're working with. So we could go out to say a 99% confidence interval. But to do that we would have to increase the size of our interval, and so that would give us less of a handle on what our population mean actually is. So there's sort of this trade-off between the confidence and also the size of our interval. So we don't want the interval to get too big, because then that doesn't really tell us anything about our population mean. So what does a 95% confidence interval mean? Well, from the point of view of a single sample, if we take one random sample and find its mean, which we represent by x bar, and based on 95%, we calculate an interval. And then we are 95% confident that it contains the true population mean, which we represent by mu. So that's if we have one random sample, so a single sample, we take the random sample, find the mean, and for a 95% confidence interval, we have an interval for which we're 95% confidence that it contains the true population mean. That's probably the main safe way of viewing it. That's what's in the curriculum statement. Another way of viewing it is from the point of view of many samples. So if we take not just one, but many random samples from the population, and in turn calculate their mean and corresponding 95% confidence interval, then in the long run, and this is going back to what I was saying in the other video, "95 out of 100 of these samples will produce an interval that contains our population mean." So although this is the safe way of viewing it, this one here is better at getting a visual idea of what we're on about. So if this is our distribution of sample means, and here's 20 samples from our population, then these are 20, here we have 20 samples. So you'll notice that for 1 out of 20 of these intervals does not actually contain the mean, represented by this line here. So we have 20 samples and one does not capture our mean. So 1 out of 20, which is 95%, does not capture the population mean, while 19 out of 20 of the intervals from 20 different samples capture the true population mean. So that's really what we're talking about when we're talking about these 95% confidence intervals. So here we have 20 different samples. 19 of these samples produce a confidence interval which contains the mean and one doesn't. So this way is good for getting a visual idea of what's going on. This is what's mentioned in the curriculum statement. I'll probably check with Mr. Ryan and make a comment about using this particular one, whether this one's also plausible to give in an exam or not. Okay, so what I want you to do, once you've finished watching this video, which is going to be very soon, is to do 7i.1 and questions 1, 2, 4 and 7. So that's also on the sheet that I've got on the website. So I want you to have a go at those in class. The rest from 7i.1 perhaps leave and do in your own time, but these ones will be good for getting an idea on the concepts that Hazy tests. Okay, have fun guys.